Good morning, everybody.
Good morning.
Thank you. Anyway, welcome to this first session, basically, of Astronomy 120. We are section 70. This is the one that starts in August. The reason why I'm saying that is because there is another section that starts late in August also. And this is for fall of 2023. So that we're clear on the stuff that we're going to be covering today. So basically, what's the purpose of the meeting today is to really to get us started on the class so that we know exactly the process, how it works, and basically what is expected from us and how we're going to be doing things. So that's in a nutshell what I was planning to do. You are not required to attend live sessions, and we will have probably a few of them during the semester. I'm hoping to at least cover some before the first midterm at least, so that we at least touch base to see exactly how we're going to complete assignments and submit them, okay? So including exams and things like that. Again, this is an online class. That means everything has to be done outside of the classroom environment. You may be on campus, but it has to be done on a computer and or at least submitted on a computer so that you have access to that. So that's part of the concept that we're at least processing with this one. This is a fully online class. However, whenever there is a recording like today, you're actually, if you cannot make the live class session, you are required still to do the to watch the recording later. And that's why we have to have these sessions recorded, so that for your convenience later on to watch them. They usually should be available sometime in the afternoon of the same day when the session is held. Worst case scenario is that the day after. So if you don't see this recording today, you should be looking for it tomorrow. So I'm saying this also for those who are watching this one recorded, because if the next session, for example, you cannot make it and expect it to be posted at least on Canvas that same evening, or hopefully within 24 hours, it will be made available. There are several factors that could influence that. One of them, of course, is my schedule with my other classes, because I have other classes actually on campus too. And also how fast Zoom will be able to make those recordings available for us. And finally, how fast is going to be uploaded to YouTube, and basically the links are created and finally again posted on Canvas. So that's basically the whole process, why it takes sometimes a little bit of time. So this is in terms of how this class at least is going to progress and what is going to be expected from this class. This class is no different than probably what you have taken online. So I'm going to share with you the screen to see the layout of the class, and also what needs to be done on your part on a regular basis to make sure that you are basically doing what you're supposed to be doing so that you don't fall behind. Because one of the things that happen, at least in the past, is people think, okay, it's an online class, so basically I can check in sometime in November or toward the end of the semester, and I should be able to complete the course. That's not going to work. It's a semester-long course. That means that you have the entire semester to complete your work, and there are assignments on a weekly basis. Some of them have deadlines that are actually within a week or less. So it needs to be on a regular basis so that you are completing all of the assignments. So you cannot really delay everything toward the end and then expect to complete the course. That's not going to work. So we have to have that out of the way. So there is a time that you need to allocate every week to do the reading, which is a requirement for this class, and I'm going to go through that. To also complete the discussion sessions that are going to be almost on a weekly basis, they're graded. And also to do homework assignments, and they're also graded. And also to do quizzes, and they're also graded. And also, of course, to complete the midterms. And that constitutes basically how your course is going to be assessed. So you do a reading, you watch the recordings also that they are posted in there. Amanda, can you turn off the sound, please? Okay, the audio. Thank you. Okay, very good. Thank you. Anyway, the point is basically you need to complete those readings, so watch the recordings and do whatever is asked you from you to do in terms of extra work to complete that. I forgot to mention that there are two other assignments also in addition to homework, reading, in terms of also discussions, and in terms of also quizzes, and in terms of exams, there are projects. Okay. We're looking usually for two projects, depending on how it goes with this class, hopefully to complete both projects, okay? Both of them will be done. At times, you may find that there are a lot of content in the class and a lot of work in the class. I really don't want you to be overwhelmed. And I want to make sure that you complete all of your assignments in a timely fashion. That's really the secret behind it, honestly, so that not to be overwhelmed and feel like there's a lot to do and not much time to do is because probably sometimes when we delay things and then get them toward the end, and then we will not be able to do that. I'm available on campus. You have in my syllabus basically access. Let me share with you the screen. Let me bring it actually to the, no, let's share it. I don't know if I can share or not. Share this page. I want to confirm that you guys can see that page that shows the syllabus on Canvas. Do you guys see it? At least one of you guys confirms?
Yeah.
Very good, thank you. Anyway, so this is the syllabus of the class. It's actually posted online. I also sent you an email version of it, and actually you can download also that same email version of it from here, which is the PDF, the printable version of it. The point is we have all of these times that you can come and meet with me. But before coming, please let me know ahead of time that you're coming on such and such time, because of the fact that I may have scheduled it for other things with other students and other classes, so that you know my load this semester, I have 6 classes altogether. So I'm not teaching this is not the only class I'm teaching, so that you know. That's why it's a good idea. Actually, it's highly recommended that you send me a message beforehand, hopefully day before, saying that I'm coming on Monday at 9:45 or 9:30 or 10 a.m. or something to meet, and this is the item that I want to meet with, to talk to you about. When you're communicating with me, usually I check the inbox, and the message pops up in here. This is actually the best way to communicate with me. Now, while you're doing that, if you do it on the inbox, there is no problem with it, because the inbox will tell me exactly which class you're coming from. So I know that you are coming from Astronomy 120, section 70, because there is another Astronomy 120, also section 71. So I know this is the section you're coming from. And if you have a general question, let's say the homework, or for example, the project or the discussion or something that you're having issues with, or the exam or something like that, then I can go straight into the topic and we start working on it, okay? But if you're gonna send me an email directly through my email address, which is also posted on Canvas, by the way, actually posted on the syllabus also. And actually, when I sent you the email, I sent it using my college email, which is in here, okay? This is my also cell phone, which is a Google number. So you have that option also to communicate with me through those. Now, if you do that, you have to be more specific, okay? You have to tell me your name, of course. You have to tell me the course you're taking, the section you're taking, and also the topic you're talking about. And if it's requesting to come and meet with me, that would be fine. But at least give me as much information as you can, so that at least we can get started on it. I don't want to. I mean, I know your time is valuable, and my time also is valuable. So we don't want to waste a lot of time trying to basically locate the resources and trying to locate your class and trying to basically find out what needs to be done. So these are the times when I am on campus. This is the time when I am available on Zoom for office hours. Excuse me. Now, these are not the only times, though. So if none of these times, because you're working or you have other classes and I didn't consult with you, I put them in, so it doesn't work for you, we may agree on a different time. You may just say, for example, how about Friday afternoon at 4 p.m.? If that's, for example, works for you, and if I'm not, if I'm available on that time, if I don't have a class or something else, that works for me too. So we can meet online. We can still meet on campus as long as it's during the week where the campus is open. Now, Saturday morning, for example, works for you and I'm available on Saturday morning, then we can still do that. My point being in here is that don't restrict yourself with what is posted in here, okay? Don't constrain yourself into that time frame and say, oh, I needed help, but I couldn't get that help because I was working or I had other classes. So that's really what I want to make sure that you guys are comfortable with, okay? Now, the fastest way and the easiest way to solve a lot of these issues is to come through the inbox and send me a message. I cannot click the inbox right now because I'm actually in a student mode. And this student is just a test student, doesn't have an email. For you guys, you come to the inbox and you can send a message to me or to any other person in there. And if you are sitting in the class that I'm looking at right now, you should have no difficulty with that, okay? I was looking for my email address and it's also in here posted too. So it's still in two places, at least in the syllabus. Anyway, my office is room 195. Actually, I'm in the office right now. And the way to access it is the physical science building has two sections, and it has the old section, and now there is a new extension to it. It's in the new extension where a lot of chemistry faculty also are located. When you come into the hallway, you don't see office number 195. You will see office number 194-196. So my office is in that hallway. So you go into that dash and you will find three offices, actually, one for the adjuncts and another one for another faculty in here in chemistry, and myself is going to be posted in room 195. So you really have to come in there. Sometimes you find that the door is locked, and the reason why it's locked is probably because it's outside of my office hours and that of the other faculty who are supposed to be also in this area, and because there is copiers and other things in here. So if none of us is here, usually the outdoor, the one where I said there is a 194-195, I'm sorry, 194-196, that would be locked. So if that's locked, then that means nobody is in here, okay? You can still try to post something in there if you want to send a message. But again, if you're coming in here, I know you're coming in here. So we already have agreed that you're coming in here. So mainly you have sent me already a request to meet, and you're coming either during one of these times or another time, and I already agreed to it. So in that case, you will not have that problem, in a sense that the outdoor will be open and my office will be available too. So that's not an issue. But if you're coming outside of those windows and you're just basically you thought of something and, oh, maybe I should ask the instructor about it. And if you come in, and like I said, if none of the other people are in here, including myself, the outdoor will be locked. So I'm sorry about that. We don't, I mean, it's not our fault. It's really, it locks automatically. So that's basically what's going on in here. But this is really my office where it's located. These are my office hours. However, these are not written in stone. We can always change them for your own convenience, as long as it works for you and I. And it's very important that you let me know ahead of time that you're coming so that we can arrange for everything so that we can meet. Now, do we have to only meet in 195? Absolutely not. As a matter of fact, we have also the STEM Center where we can meet at. The STEM Center, it's in the main hallway for the physical science building. When you come in, there's usually the offices on the right-hand side, but you don't have to go to the offices on the right-hand side. Just go straight into the hallway for physical science building on the first floor, all the way to the end. And the STEM Center is located in room 121. So physical science building 121, that's where the STEM Center is. We can meet there. There's a lot of space in there. There are private rooms basically where we can meet in there. We can meet in the open area. And if you don't find me, actually, that's a great resource also to take advantage of, namely the STEM Center, where you're going to have access to tutors in there. So they have resources in there. You have a question, you don't find me, you're struggling, for example, with trying to find, for example, I don't know how far an assignment is asking you, for example, to solve a problem with the position of Jupiter, for example, given its angular size, and you try to use a formula, and for some reason you're finding numbers because probably you did not know how to convert from, I don't know, from astronomical units, for example, kilometers or vice versa, or something in terms of things like that, then there are resources in there in the STEM Center also that can help you. Obviously, I'm hoping that we can resolve these things. You can meet with me, but if for some reason you're there, you can also get those resources in the STEM Center. STEM Center also provides you a room for studying on your own, so you don't even have to have nobody bothers you or anything like that. You can go into one of those tables basically and get all of the things. There is a chargers in there. They usually have all kinds of snacks also, especially if you come in the morning, and they have all kinds of things in there. So you can put your phone to charge, you can put your computer plug the computer in and start working. They also have computers, as a matter of fact, that you can actually also use. So you don't have a laptop, you don't have access to your internet, and there is something that has to be done, you can still go into one of those computers. Of course, you have to get the permission from the personnel in there, and usually there's all kinds of tutors and also the people in charge in there. So, and then you can go and get the computer and start working whatever you want to do. So that's also another thing. You can also go and use the recreational area of the STEM Center where you can go and have your lunch in there. So what I'm trying to say in here, there are resources that you can take advantage of. There is office hours also that you can take advantage of, and you really should not have difficulty trying to progress through this class or any other class, as a matter of fact, at least the ones that are in our division in here for the sciences. Okay. Makes sense so far, everybody?
Yes, it does.
Yes,
Okay.
it does.
Okay, very good. Thank you.
Yes.
So this is in terms of the format. This is in terms of the basically logistics of this class. The class starts again, we started already this week and ends on December 15th. If you look at the syllabus, and I'm not going to go through the entire syllabus, this is how you're going to be graded, of course. Projects at this point, you could have 2 projects. I did not really decide yet, but there is a minimum of 1 project, and the 2 projects usually that I assign have to do. I mean, I may change one of them or 2. Okay, but usually the lunar observation is a requirement. The lunar observation is a 4-week assignment. That means a whole month, basically. You're going to go and on a specific date where you're going to locate the moon, describe its position, its location, and also its shape and how it looks like and everything else, and continuously do that for 4 weeks and then report the data. The other project that I gave in the past also had to do with the with how Mr. Kepler was able to prove or show that Mars is actually has an orbit that is not a circular orbit, but rather it's an elliptical orbit. That project gives you raw data, actually data that people have collected over a long period of time, many years as a matter of fact, and you're supposed to make some basic assumptions and come up with the fact that the path of Mars is actually elliptical path. And also not only that, but you go a step further and find the shape of the ellipse, the shape of the path of Mars. That is a very, very big deal because that's really the first law of Kepler. That's how Mr. Kepler came up with those laws governing all the bodies that revolve around the sun, not just Mars, of course. But Mars is a little bit was easy to do at that time because you can follow it. And the year on Mars is almost 2 years of the Earth's years. The Earth goes 12 months around the sun. Mars makes it in about 22 months. And of course, he had other data also related to Venus, so that's really what confirmed his first law, which is now bears his name, first law of Kepler. So that's another project also that potentially and most likely we're going to have that one too. Again, you will have tutorials, you will have help, and if for some reason you still have an issue on how to plot those data and how to trace them or how to do the observations for the moon, you can still always ask for one of those sessions or go to the STEM Center, make it happen. Okay, we really want to make it happen. I know some of you are sitting in my other astronomy class, which is 125, which is the lab version of this class. But that one actually has a lot of hands-on and it's separate from this one. So it's basically lab and does a lot of observations and a lot of things like that one. But it's mainly lab activities and things like that. So Astronomy 125 is different than this class. This focuses mainly on the concepts and we build them as we go. Okay. So again, these are some of the stuff. So I leave the rest for you guys to read, including basically of each, and that's really what I was geared toward in here. Each week you have assignments to read certain units. Okay. Each week you have assignments, and I'm going to post more and more of these things. So let me go back into the models in here. Before you do that, let me click on home. Okay. Okay, did not. Okay, good. Let me click on home. This is probably how it looks to you when you first come in. This is an old recording. Okay, that's still useful, but this is basically when you come to home, these are the generic information and all of the stuff that is actually mainly the syllabus, except the syllabus updated for this semester. And this is where you really want to go, the models on a regular basis. You click on this link, okay? That is where you're supposed to be on a daily basis. Now, you asked for something, you needed something to do, and you need something in general, you can always click on this discussion item. This is not a graded assignment, by the way. This is an open discussion. You can ask a general question from your entire peers from the class, okay? If I don't get to it in time, or probably if I don't explain it right, or if I don't have the correct explanation, or maybe I don't even have the right angle to it, okay? Someone else might come in and hear the discussion and give you that different perspective, and it makes better sense probably to do it that way. Or maybe if you need help, maybe you need to meet somewhere to get something done, that's actually a good place to go and ask that general question from the entire class. We have about 40 people in this class, so I'm sure there is one or two other people probably who also might share your, first of all, if it's a question, they might be able to, oh man, I was thinking about the same thing, and now you ask it, and I'm glad you did ask it because I was going to ask that question, but I'm glad somebody did ask. Or I was really struggling with this one, but it never occurred to me to formulate it this way, or even to ask the question, but I'm glad somebody else did. Then at least I will follow up to see what's going on. So this is really the purpose of this open discussion item, so that you guys go in there and try to enrich the class by basically either inquiring or asking or participating or even contributing to that discussion. I will try to monitor it on a regular basis and try to also be as a participant in that discussion. And hopefully we can get this course progressing that through that one. So that's one way, okay, of also getting help in this class. Now, as I was saying, this is really your bread and butter. This is what you do on a regular basis. Right now, the reason why you don't see more content is because I'm still looking at as a student view. There is far more content down the road. There is all kinds of assignments, and I'm going to open some of them this weekend, I'm sorry. And you will see the content as it's going to flow. For right now, you only are looking at week one because we are at week one. So, and that's really the focus in here on the rules. This you will only see it in this unit and this model. You're not going to see it in week two and so on and so forth. But every week you're going to see the objectives for the week. You're going to see discussion items. You're going to see the content. You're going to get the PowerPoints, and you're going to get some recordings in the past. That should help guide you in your reading. That should help you guide you in your how the class is progressing. So please watch those recordings. Some of them are long. Some of them are about an hour or so more actually. So you might split it in chunks. Let's say, for example, you watch the first 15 or 20 minutes, then you can go and do other things and come back and finish them. Because similar to this one, these are recordings in the past. Actually, they were following the content. Okay, so let's get into the objectives so that we see how this thing works. Again, in the objective, you will see some of the assignments that are posted and when they are due. And this will build up over time. Things start to fall from it, the things that were due and already have passed. things that have been assigned, again, they're going to pop up, and things that have been assigned before, but they are still due also are going to show. So this list in here, the assignments is going to grow and shrink depending on the week. So an assignment that was due, for example, let's say this last Monday, is not going to show today because it's not part of the assignments that are due in the future. An assignment that popped up yesterday and it's due, for example, next week, then it's going to pop up. An assignment that has just been basically assigned also is going to pop up. So this list grows and shrinks depending on the week. Also, you will have your reading assignments in here, which brings me to an important point. This book that we're using, okay, is actually a very good book because all of the reading is actually supposed to be a very light reading. I'm looking at unit, but I know some of you, and probably you're using the Brightwave basically link, which is you have the electronic version of the book, which is fine. The amount of reading you do on a regular basis is really not that much. I'm looking at unit 5 in here, and unit 5 starts on page 33, and it ends really on page 38. So 33 through 38, that's 5 pages. Even I can read 5 pages, okay? And I'm not taking a class, okay? But that's not the only one. I have unit 6 also. That's also part of the reading assignment. So I'm going to look at unit 6. Unit 6 starts in here, and that's from page 40. And if I look to it, unit 6, and what is this one? 6 shell. Yeah, it ends on page 49, okay? So page 49, this is 9 pages. Or is it 10 pages? 10 pages, 10 pages, sorry. From 40 to 49 is 10 pages, okay? Anyway, that's the amount of reading you're expected to do. Anywhere between 15, 20 pages on a regular basis, that's a sizable amount of reading. So you're expected to do that, okay? You're expected to do that. Now, reading combined with the videos that were posted in the past, you should really get through the content in here. Also, if you have questions, please don't forget to send them through the open discussion or directly to me. If you don't want people, for example, like, by the way, in the open discussion, you're not going to discuss sensitive issues, like, for example, grades, or if you have any personal things that you need, or please don't refrain from posting those things in the open discussion. You would want to keep that basically private. You don't want to share that with the rest of the class so that we resolve what needs to be resolved in there. So the open discussion is just for the general questions. Like, for example, I didn't understand the difference between a sidereal year and a solar year. So what's the, or a sidereal day and a solar day? What's the difference between them? I read it. I listened to the instructor explaining it. Can you give it to me in a different perspective? And somebody else might intervene and say, okay, here it is, okay? That's good. That's actually a good point to discuss in the general discussion, but not, for example, in the, if you have a specific question related, for example, to an issue with your posting, for example, of an assignment or something else, or you need an extension, for example, or for some reason, for example, the upload did not work. Let's have that on a basically personal level so that we can address that. Okay. Yes. Are we clear so far? So good.
Yeah.
Very good.
Yes.
Very good. So this is basically how we're supposed to do. You have some of the objectives in here, so I'm going to move on. This is a discussion item that some of you already have replied to it. Usually my discussion items are very, very thorough. In a sense, you're asked to do something by specific dates, okay? By specific dates and also specific rules and things like that. So I'm reading through this. It's a lot, doesn't it? I don't have time. I have all the things to do. So what should I do? One way of getting through this is actually show me the rubric. And the rubric, it tells me how am I going to be graded. Okay, it says that the initial reply has to be, the initial post has to be by 8/23, which is today is the 16th, and 23 is next week, Wednesday, a week from today. And I have to have 4 items in order to get the full credit. The second one has to be by by August 26th, and all criteria I met. So I really have to, in order to get 20 points on this assignment, I have to meet this requirement and that requirement. So what are all these 4 items included? So let's go. 4 items that are included are these items. Okay. So the first one, please tell us a little bit about yourself. So check, I did. Share the link for the video if you find it, or post or something else. Check, I did it. Identify an argument for that was made. Check, I did it. Then check this one. So I can grade myself. I don't need the instructor to grade me. All I have to do is meet the deadline and meet also all the criteria, and I got a grade 10 out of 10, and nobody will take it away from me. And if the instructor makes a mistake and say, oh no, you have a 5 because, or a 4 or 6 or 8, no, I met all the requirements and here they are. Deadline, everything. So I can grade myself. I really don't need anybody to grade me. Okay, that's 10 out of 20 though. Still have the other one. Okay, so I have to do this now to get the other 10, and that's it. This is a little bit more thorough, honestly, of a discussion session. That's why it's more detailed. Others are actually a little bit shorter requirements. So in a sense, the others will get less requirements, and you should be able to meet 1 or 2 criteria, and that's it, and get your full grade for the discussion. All my assignments, they have rubrics. Look for those rubrics first before you start doing things, before you start answering something, and then at the end realize that you probably missed an important key component to it, or added something that was not needed. Okay, so that's how we're going to process with this one. Obviously, some of you have posted in here, and you can see their posts. But let me go back into the model in here, so that you can reply to them. Because if in case, for example, you missed the first one, at least you can get partial credit for the second one. You can get the full second one, and maybe you can, what should I say? What I was saying, I mean, you can at least get the credit for the second part. You don't miss everything. So again, this is the content. Again, every week you'll have a summary, basically, of the content that is covered in that week, basically, the concepts that needs to be covered in that week. In addition to the PowerPoints that are basically posted. So let me go back into the models in here, because I really don't want to load both of them, because so you have the PowerPoint for Unit 5 and the PowerPoint for Unit 6. This is not in lieu of reading those units, though. You really have to do the reading for those units. I mean, they give you like a summary of what those units are if you want to. So let me click on one of them. Okay, I loaded fast enough. So this is the PowerPoint really I'm looking at. And it has the objectives: describe the celestial sphere and explain what makes it a useful model of the sky. So basically, when you go outside and look at the sky, everything is like a scenery above your head. Everything is some sort of in a sphere above you. Okay, you can point into this star, that star, that star, that planet, that the sun is actually during daytime, and you can look for another object this way and that way. So left and right. Obviously, you're not looking at the whole sphere. You're looking at a half of the sphere, because the other half is actually underneath you. Okay, it's on the other side of the Earth. So that's really a hemisphere, not the full sphere. But if you wait for the Earth to spin around a little, you're going to describe more and more of that sphere. And if you travel around the Earth, you're going to actually cover the entire sphere. So it's really a sphere. Okay. Okay, list the points of reference using the location of the sky. Obviously, the point immediately above you has a name, which is the zenith. The point immediately on the opposite side of the zenith, which is above your head, which is below your feet, that's also called the nadir. Both of them are actually derived from the Arabic words. Zenith is from the tip of the head in Arabic, and zenith is the opposite, the other way. The word in Arabic is more like symmetrical. Okay, a lot of these words that you see in astronomy are actually a combination of different cultures contributing to it, including the Arabic culture. And here, a lot of the stars actually have those names. So that's basically some of the words that you see. Obviously, that's not the only way. Also, so if I'm standing like this one, I can spin myself one way or the other. One way I can do is look at the north, and then extend my arms. then in this case, my right hand will be, if I'm looking north, it's going to be east, and this is going to be west. The line that connects my due north above my zenith, above my head, and extends all the way to due south. It's not a real line, by the way, it's an imaginary line. That is called the meridian. The sun arises in the east, at noon crosses the meridian, and in the afternoon it goes toward the other side, toward the west, sets in the west. Where it rises, that's the horizon, and it's going to fall back into the horizon. So this is basically some of the terminology that is covered in this chapter. Okay, so these are some of the topics that are covered in this chapter, and you need to be familiar with them because you're going to be referring things in the sky. If you want to, for example, locate a star tonight, is Procyon? No, Procyon is not. Procyon is part of Ursa Minor, and Ursa Minor is one of the constellations that you see in the winter. Okay, so Ursa Minor. I'm sorry. Did I say that? Canis Minor. Sorry, Canis Minor, Procyon, and actually, what is that? The other Ceres and Betelgeuse are part of the triangle, the winter triangle, and that's an asterism. That's also another thing that you're going to be learning in these 2 units. The asterism, the group of stars, basically, they make a shape. So these stars, these 3 stars, Procyon from from Canis Minor, and Ceres from Canis Major, and also Betelgeuse from Orion, they form a triangle in the winter called the winter asterism or the winter triangle. So that's a group of stars. They form a shape that you recognize at night, okay? And you have constellations, and there are 3 types of constellations that you can see. All of these things you're going to learn. There are 88 named constellations following the naming that was started by Ptolemy and later on adopted by the Astronomical Society. So including the ones I mentioned already, Canis Minor, Canis Major, Orion, already mentioned Ursa Minor, Ursa Major, what is it, the other one, Taurus, Leo, Cygnus, and Cassiopeia, which is actually part of another kind of constellation. So there are 3 types of constellations. There are the Cassiopeia type, basically the ones that are called circumpolar constellation, and that includes, of course, Ursa Major, Ursa Minor, and also Cassiopeia and a few other constellations. And you have the zodiac constellations, and usually there are 12 constellations, and those are the ones that you can see following basically the path of the sun, and those are sometimes associated with the astrology. And there is also the seasonal constellations, the one that you see one time in one season, but you don't see in the others. I mentioned already Orion, which is one of them. Okay, so those are some of the things that you are going to be familiar with. Do you have to remember all constellations? The book says no, and of course I say no, but it's a good idea to know some of them. It's a good idea to know some of these constellations, to refer yourself in the sky, to start to know where you are in the night sky, okay? So again, these are some of the things that you can do. And of course, I didn't go through the entire PowerPoint in here. This is basically a PowerPoint. This is Leo. I don't know if I mentioned Leo for you guys. That's another constellation. And also this is Cygnus, okay? Or the swan. Leo is the lion, of course, okay? So these are the difference between a constellation and asterism. So I mentioned the fact constellation is already a named, basically, group of stars that form a big region in the sky. Asterism is actually a shape, okay? If you guys remember in the movie, what is it? No, not the Matrix, the other one. Men in Black, they talk about Orion's belt. Orion's belt are 3 stars, basically, in the middle of Orion constellation. And they're in Nilam, Al-Mintaqa, and I forgot the 3rd one. They're actually all Arabic names also. They form a straight line. Okay? That's actually very, very important asterism. That's an asterism, that's a constellation, part of a big constellation. Okay, And not all asterisms, they belong to the same constellation. An asterism is a group of stars that form a recognizable shape. I mentioned already the winter triangle, and that actually coming from 3 different constellations. Orion on one side, Canis Major in the other, Canis Major in minor in the other side. Okay, so Orion is the hunter, and he's 2 dogs. He's 2 faithful dogs. That's basically where the mythology is coming from, which is another point that you really have to remember. Mythology is just like mythology. That's it. It depends on the culture, so it's not real stuff. So when you hear people talking, or when you see me talking about this one, don't take it like it's like kind of something to. It's not facts. It's based basically on what people try to associate these things with some sort of a kind of a what they think or what they imagine could have been or something like that. No, it's not real stuff. Okay. Anyway, so we have that. And I don't want to really click next, because if I click next, it's going to take me to the next also PowerPoint. We're not going to go in detail about that, at least today. And then, of course, this is the recordings. Today's recording is going to be posted in below, okay? Below this one. So this is from previous classes, okay? And this one, I think it's from 2022, which is a year ago. And this one also, I think, also from the fall of 2022 too. So you're going to have a different one in here coming from today. And I'm going to send a message once the recording is available with a link to it so that you guys will have access to it. I have a YouTube channel. If you choose to, you can go and look at the stuff in there. And if you want to, of course, you could subscribe to it, especially if I post stuff. Usually that's the fastest way of getting content. But when you go there, please make sure you're filtering your search, because there are a lot of videos in there, and a lot of them are not relevant to your class. So look for Astronomy 120. Doesn't matter which section that is. Astronomy 120, you should have a lot of content related to your class, homework assignments, and also in terms of projects, and in terms of lectures and stuff like that. So that's on the YouTube channel. And if you're looking for it, just put my name in there, DJ Bouzidi. You should be able to find the YouTube channel, and you should find the content, sift through it. Usually through the title, it will tell you what course it is. So if you're looking for something and you see Physics 202 or Physics something else, Physics 101 or Physics 152 or something, that's not your class. You don't care for it. Or even Astronomy 125 or a different course of astronomy, that is not your class. So just focus on the class that you have in there, and you should have no difficulty for finding the resources that you have in there. Okay, so let me stop sharing, because I want to also open another software to share with you, because I mentioned it in the syllabus. Let me first of all load it. Stellarium. For those sitting in Astronomy 125, you guys don't worry about this section, because you're going to have a lot of this software, because we're going to use a lot of it in the lab. Not all of the labs use Stellarium though, but some of them do. So, oh man, it blocked the whole thing. Can I go back into where's the minimize the window? It opened for me, but it took the entire screen. Now I have it. Good. Let me move it to the other side. Can I move it to the other side? I have to move it to the other screen. I cannot move it to the other screen. Okay, never mind. So let me share it with you the way it is, okay? Or maybe move this one to the other screen. Okay. Move this one to the other screen and keep this one. Okay. So let me go back into share. And I don't want to share the entire screen. I'm going to share the app. Are you guys looking at what looks like basically a field with grass on it and some trees and things like that?
Yeah.
Okay. This is how stellarium loads when you open it, okay? Let me get this thing out of the way. This is how stellarium loads when it opens up, okay? So you have on the bottom left, you can actually fix it on the screen. And you have the bottom also that you can also fix anything. This is really basically what the software is. Right now, it's giving you how the south of where we are right now. It's looking at the Earth. We are on planet Earth in San Bernardino, and we are 0 meters above the sea level. Basically, we're at sea level. This is how the sky looks like. Obviously, we're in daytime. And if I look higher in the sky, I should see the sun. So that's really how the sky looks like right now. This is east. I'm looking exactly what I'm facing right now. So the sun, if I go outside, is just above the horizon. It's not horizon, it's really in the middle of the sky. I can see its magnitude, super bright, -26, super, super bright. Okay, we're going to talk about that one down the road. The magnitude, the smaller the number it is, the brighter the object is. It's kind of counterintuitive. I mean, you would think that an object that is bright will have a higher magnitude than an object that is dim. Actually, it's the opposite. Okay, sorry about that. So, and that's one of the things you're going to learn about, okay? You have a lot of information in here. You have the rise, 6:12 this morning. You have also the set, which is 7:36, chooses the military time, by the way. You have a lot of information, but at this point, I'm not really interested in the sun. I want to see, for example, tonight, we are in San Bernardino, and I want to see south still, pointing south. By the way, this is not how the outside looks like if I walk outside. I'm actually on campus right now. So this is generic image, okay? So I'm going to go to the time. First of all, I'm going to stop the time, okay? Because the time was actually running in here. So I'm going to go into the time in here and change it to tonight, okay? Right now it's telling me 9:47. So I'm going to make it around 10 p.m. 10 p.m. military time is 22, okay? So actually it's 11 p.m. because I just put it. So I'm going to put 00 in here and make sure I also put 00. So we are August 16th of the year 2023. It uses military time, starts with the year, month, day, hour, minute, seconds, okay? So this is how the sky would look like if I'm looking at it through the south in here today at exactly 10 p.m. And for some reason, I can move this. Okay, I was able to. So this hazy thing in here is actually the Milky Way, the center of the Milky Way. And if I follow it, that's basically how everything is. If I click on any object, it gives me the details of this one, okay? So this is part of the Sagittarius constellation. Sagittarius constellation is where the center of the Milky Way is. That's where our big black hole is. And so if you look tonight south, basically you're going to see the center of the Milky Way. But that's not what we're after, actually. Let me turn on something in here, which is the constellations. Okay, so I'm going to turn on the constellation lines and actually the names also of the constellation. Scorpius is going to be visible, okay, in the night sky. Sagittarius, I mentioned that already. That's where our black hole is. So it's going to be actually looking at south, looking a few degrees above the horizon, okay? So it's how much degrees in here? We're looking about 11 degrees in here. What is it? No, the longitude. I can't see it through the screen correctly, okay? So the altitude looks like it's 21 degrees, 21 degrees. 21 degrees, basically, if you open your hand like this is 0 degrees, okay? If you open it wide, it's 90 degrees, basically. Halfway, it's 45 degrees. Half of halfway, that's about 21 degrees. So that's basically if you go outside and hopefully you're not blocked with anything. You don't have mountains or you don't have, I know I'm looking south. South is towards, I'm in San Bernardino, so south is where Riverside is. There is not much mountains in there, but there's a lot of buildings probably in the way. So if I step a little way away from the buildings, I will be looking at the center of the galaxy. And there is another problem in here in San Bernardino, that's the light, too much light. So there's a lot of light pollution in here. And I think today is also kind of cloudy also. But the point is, this is how the sky looks like. Okay. And if I look due north, there's an important, something very, very important in the north. So if I look in the opposite direction, okay, and this star, so due north, keep on looking until you find the brightest star, which is actually a dim star, relatively speaking, especially in San Bernardino, it doesn't look too bright at all. It's this one. This is Polaris. This is the northern star. This is basically where all of the objects revolve around. So right now the time is frozen. So if I'm going to allow the time to move, you will see everything starts to move on it. So I'm going to speed up time. That's a nice thing I can do. Right now it's 6 seconds past 10 p.m. That's still not fast enough. So I'm going to move faster. Now the seconds are actually zooming faster. And so I'm going to go even faster than that. Now the seconds are even moving faster, and the object in the sky starts to move. This is Cassiopeia. Cassiopeia is a circumpolar constellation. It looks like the number 3 backward, basically. Oh, the number 3, I'm sorry. Because when it's on the other side, it's going to be the number, like the E, the letter E, okay? So if you look at this, this is a shape that you can recognize when you go outside at night, okay? So this is Cassiopeia. It's an important, of course, this is Ursa Minor. It's like a handle, basically, a pan with a handle. So right now it's actually kind of backward handle, backward pan, okay? And so let me speed up this one in here a little bit more because it's going too slow. The entire sky is spinning around Polaris. Polaris is sitting in the middle of the sky. That's why it's called the northern sky. Obviously, the sky doesn't spin. The objects are actually stationary. What is going on in this case is the Earth is spinning. Okay. And so right now the daylight is starting to come in because we are at, what time is it? 6 o'clock in the morning. But it's still showing you, because I turned on the constellation, it's still showing you the constellations. So Cassiopeia will be actually the letter E in the morning around 10 a.m. tomorrow. Okay, so we're looking at the 17th, which is tomorrow's date. These are some of the things you could actually go and see yourself. You don't need this software to help you see it. You don't need anybody to basically do this for you. You can see it on your own. Okay. Obviously, if there is a solar eclipse tonight or tomorrow during daytime, you can see the actual sky. So let me remove this one in here. The effects of the, as if we don't have an atmosphere. So this is how the sky would look like if actually there is a solar eclipse, at least for a few minutes probably during the solar eclipse. So this is some of the things you can do. Of course, I'm going to stop the time now because we are still August 17th at 11 p.m. So shortly turn to August 18th. Now we're on Saturday morning, Saturday, early in the morning. So that's how, looking due north, okay, this is how it looks like, okay? So again, these are some of the resources that we have, and I actually urge you to guys have this software for you guys. It's going to help you. Did somebody post something in the chat? Okay, very good. Yeah, it's going to help you in this class, of course, locate objects and stuff like that, but also this software actually I recommend it very highly, even if you're doing amateur astronomy. If you go and invest in a telescope, for example, 5-inch telescope, it costs about $200, $250. A nice one, a very nice one, those collapsible from Astronomers Without Borders. At least it helps you locate objects so that you direct your telescope in there and start looking at them, okay? 5-inch telescope will be something nice to look at objects like deep sky objects, like, for example, I don't know, nebulae and things like that, okay? A larger telescope is kind of a bigger investment in it, like an 8-inch telescope or something. And not only that, but the logistics of it becomes a little bit of a problem. Trying to take it from a location to a location becomes an issue because it's heavier and more massive. So 5-inch telescope is actually perfect for a lot of the things you do outside. I mean, looking at objects. If you're looking for a planet or for an object using this software, you can come to the search. What is the search? Yeah, the search window. And let's say, for example, I don't want Polaris. I'm looking for Jupiter, okay? Or, yeah, any object. So let's look for Jupiter. So Jupiter location, let me turn on, what time is it right now? It's at 5 o'clock in the morning. So let me go back in time. We're still in Saturday, by the way. Saturday, let's put it around midnight, okay? Just past midnight, okay? Actually, way past midnight. So right now, around 30 minutes past midnight, okay? And let me turn on the haze again. So it's still kind of dark. So here in San Bernardino, it's going to be on the east side, but it's going to be way above the horizon. It's going to be below the, so let me stop the time. I don't want the time to be moving now. So I want to be half an hour past Saturday. And I'm looking at Jupiter. It gives me all kinds of information. Of course, Jupiter is a planet. It's not a star. And where is the position for this one? It's 15 degrees. It's actually a little above the horizon. So if you had difficulty already looking at the Polaris earlier in the day, or whatever that planet that we were object that we were looking on, I forgot which one. No, it was not. It was actually Sagittarius. Okay, that's the one 21 degrees, because Polaris has a fixed number. It's about 34 degrees because of our location, 34 degrees. But this one moves. Planets move. Planets, the word planet really stars that move. So if I zoom in into this object, and there is actually a zoom in feature using the mouse, I think. What is the zoom in feature in here? It's not zooming in. I'm trying to go with this one. Yeah, I can use the. No. For some reason, the mouse is not responding for me. Give me the zoom capability. By the way, I'm not an expert in this software. I don't think anybody is. There's a lot of features on it. And this is supposed to be the, so let me try to turn on the telescope in here, okay? And try to place Jupiter inside. And so now, with a little bit of this telescope in here, I can see Jupiter and actually some objects next to it, okay? This is Callisto. It's one of the moons of Jupiter. This is actually, that's actually a star behind it. This is actually Ganymede, another moon. And if I let time move a little, let's make it at 1 o'clock, I probably could pick up more moons of Jupiter, because Jupiter is super bright right now. And it's, let me turn on the light again. Turn off the light, I should say. Okay. And now there is another object I can clearly see in here, and that's Europa. Okay. So if I have a telescope and I didn't pick up the properties of this, these are binoculars. Yeah, this is generic telescope. This is not even a decent telescope. Anyway, so if I really have a telescope, this is what I'm going to be looking at. I'm going to be looking at the moons of Jupiter, okay? And one of them is going to be just in front of this star, Callisto, okay? That's 4 moons, by the way, Jupiter. We're going to be looking at 4 moons. So again, this is some of the things that you can do. I know I promised this class not to go over an hour, and it's almost an hour. So I'm going to close this thing in here. And it's an introduction to the class, and also introduction to some of the tools we're going to be using and how we communicate and what we do in this class. Okay, any questions? No? Well, I'm sure the questions will come along down the road. This is just the first week, okay? So please bring them on, and let's enrich this class and make it a nice experience for you guys, for all of you, enrich, and hopefully you get a lot from it. Sounds good?
Yes.
Very good. Thank you, guys. So I'm going to stop the recording, and I will, and please watch for the messages that I will be sending on a regular basis. Thank you.
Have a good day.
Thank you.
Thank you. Okay. Okay, bye.